The third quantity which is important in electricity, that quantity is known as resistance. What is the meaning of a resistance? Resistance means property of a material to stop or slow down movement of the charges. So when the material try to stop or resist the movement or the flow of the charges, this property of a material is refers to resistance. Like example, if you have two materials A and B, and for material A, the three charges enter from, or five charges are entering from left hand side. And for material B, five charges are entering from left hand side as well. But what happened when the charges are coming out, you will find only two charges are able to come out from other side of a material A, and for material B, four charges are able to pass out to the other end. Which material is having a higher resistance or higher or greater capability to stop the movement of the charges? So which material is having a high resistance? A will have a high resistance, or it will have greater capability to stop the flow of the charges, where B is having a lower resistance. So simply the resistance means the property of a material to stop the flow of the charges. For example, if there is another material which block the charges completely, does not allow any charge to flow out. So if five charges are entering from one end and no charges are able to pass through, so if no charge is able to pass out from other side, so what does it means? It means this material is having infinite or very high resistance. Means it does not have a finite value, it is infinite resistance. Infinite resistance means very high resistance. And the material which is having infinite resistance or does not allow the charges to pass through at all, these materials are known as insulator. So material A and B are the conductor. A is a conductor, B is also a conductor. So when we compare the resistance of conductor A with conductor B, conductor A is having a high resistance because it allows few charges to pass through. Material B is having a low resistance because it allow greater amount of charges. Like if 5 enter, 4 it allow, so it has lower resistance. That's why it allow greater number of charges to pass through. And material C is an insulator. Insulator means the material does not allow the charges to pass through at all. And the property of a material which stop the movement or the flow of the charges, that property is refers to resistance. Is it clear? The concept of resistance? the property of a material to stop the flow of the charges. So example, you can see here, 5 charges are entering, but as a result, 2 of them are able to pass out. Here, 5 charges enter and only like 4 out of 5, 4 charges are able to pass out. So this material stop only 1 charge. This material stop 3 charges. So which material having a greater tendency to stop the charges? So material A is having a greater tendency to stop the charges. And what we call this property, we call that as resistance, which means the property of a material to stop the flow of the charges. And how we can find the resistance? So how we can find resistance is simply a ratio between voltage and current. Voltage divided by current, what you will get? You will get the resistance. And the SI unit of resistance is ohms. So how much current can a cell push through a resistor? That depends on the property of a material which called resistance. And the SI unit of resistance is ohm. It is denoted by a Greek alphabet omega, where resistance is voltage divided by current or potential difference divided by current. So if you want to find the resistance of any component, what you need a voltage and you need a current. So example, if I say if there is a lamp and this lamp, the voltage across the lamp was 2 volts and the current 3 ampere was passing through it, or 4 ampere was passing through it. What is the resistance of this lamp? If a lamp is having a voltage across the lamp is 2 volts and a 2 ampere is passing through it. So what is the resistance? Resistance is voltage divided by current. Voltage divided by current. So yeah, it will be half or it will be 0.5. Why? Because it's voltage divided by the current. So voltage or potential difference is 2 and the current is 4. So 2 divided by 4, that's equal to 1 by 2 or half, or you can say 0.5. And how we write or represent resistance? We say ohm. You can write ohm, OHM, or you can use this Greek alphabet omega, which shows also the unit of resistance. So it's half ohm. And this is how in electrical side, this is how the resistors look like. Maybe you have seen some circuits or circuit boards. So the component which this is a component which is resistance, and these colors, the strips are there, you can see the lines. These are called color coding of resistor, because every color is represent a specific numeral value. You don't have to learn the color coding of a resistance, but the colors here representing the number. So example, the first color is representing 2, like brown color is there, it's representing 2. The second color is green, which represent 4. And the third color is representing power of 10. So it is power of 10. So it is 2, 4 exponent 10 raised to power 2. And when you solve, it will come out 2400 ohms. The color coding you don't have to learn. This is just an information, extra information which I give. It's not a part of the syllabus or course outline. And this line? Yeah, the last one, what is represent? It is known as a tolerance, means like it can be 5%. Your answer may be 5% more than what you calculated or shown here, because when they mention it is 2400 ohm, but practically when making this resistor, maybe it can be 5% more or 5% less. So this strip is representing a variation. It can have a golden strip here. It can have a silver strip. Golden strip is representing 5% variation. Silver strip is representing 10% variation. But this is the extra thing. You don't have to learn. So you can see here. So three colors always you will find. There are four strips. First two colors are representing a number. Then the third color is representing a power of a 10, and this is called a tolerance. Tolerance means like the variation, it can be 10% more or 5% more than or less than what you calculated. So the circuit symbol for resistor, it's a rectangular box. This shows a circuit symbol for resistor. Is it clear the concept of the resistor? Resistance is a property of a material to stop the flow of the charges, and practically if you want to calculate the resistance, it's a voltage divided by current. So for a circuit example, if you have two lamps, they are connected one next to other. What is this combination, series or parallel? So this is a series combination. When one component connected next to the other. So we call that series combo. So example, this is lamp 1, this one is lamp 2, and this one is the battery. To calculate the resistance, what I need voltage and I need current. How I can find the voltage? Which apparatus, which instrument can be used to measure voltage?
Voltmeter.
So we use a voltmeter. And how the voltmeter is connected? In series to the component or in
before or after the battery?
No, the voltmeter to the component, it is connected in series or parallel? The voltmeter is always connected in no, voltmeter is connected in parallel, ammeter is connected in series, because voltage is same in parallel.
Yes.
So voltmeter is always connected in parallel, and current you measure by ammeter, and ammeter is always connected in series to the component. So if I say connect voltmeter and ammeter to measure resistance of, or to calculate resistance of L1, lamp 1. So if I want to measure the resistance of lamp 1 or L1, because voltage divided by current will give us the resistance. So I have to connect an ammeter. So how I will connect an ammeter? So ammeter should be either before or after. So this will give us current. So we will have the current. And voltmeter to measure the voltage. So we'll connect a voltmeter in parallel to the component only which we want to measure. So if I know the voltage, example, this voltmeter reading is 5 volts and the current was 3 ampere or 2 ampere. What is the resistance of this lamp? What will be the resistance of this lamp? if I know the voltage across lamp 1 is 5 and the current is 2. So resistance is voltage divided by current. Voltage is
5 divided
5
by 2.
divided by 2, which is equals to 2.5 ohms. So whenever we want to find the resistance, so directly you cannot measure the resistance. Calculate your resistance can be measured from for a component by measuring the voltage and current. There is a device, there is an apparatus which is known as ohm meter. Ohm meter can be used directly measure the resistance, but because ohm meter is having lot of errors, it's practically not accurate. That's why this technique, that measuring a voltage and current, will give you the more accurate result. So this technique is used. If I want to measure total resistance of the circuit, so if I want to measure total resistance of the circuit, what type of errors are there in ohm meter? Ohm meter is having, because ohm meter is using batteries, and batteries also have a resistance which is called internal resistance. So the overall resistance of the circuit increases when we use ohm meter. But here voltmeter and ammeter does not have their own batteries. That's why they don't contribute to circuit resistance. So if I want to measure the total resistance of the circuit, so I need total voltage and I need total current. So from where I will get the total voltage? So I will get the total voltage by connecting a voltmeter with the battery. And where I will get the total current? I will connect an ammeter next to the battery. This will give me the total voltage and this will give me the total current, and total voltage divided by total current, I will get the total resistance of the whole circuit. So if we want to measure the resistance of the whole circuit, we connect voltmeter parallel to battery and we connect ammeter next to battery, because this will give us the total voltage and this will give us the total current which is coming or passing, and total voltage divided by total current will get the total resistance of the circuit. But if you want to measure individual, like example, if I want to measure resistance of lamp 2, so I will connect a voltmeter parallel to lamp 2 and I will connect ammeter next to lamp 2, so I will get the only resistance for lamp 2. So you have to be sure, according to the question, you have to connect a voltmeter and ammeter. If in a question they say connect a voltmeter or ammeter to measure the total resistance of the circuit, so the voltmeter should be parallel to the battery and ammeter should be series to the battery. But if you are finding a resistance for any individual component, then voltmeter should be parallel to that component which you are measuring a current, and ammeter in series with a component you are measuring a current. So I'll give another example. If we have three lamps connected one next to other, so this is a series combination. If a question is, and these are the lamp, this is lamp 1, lamp 2, lamp 3. If a question is connect voltmeter and ammeter to measure resistance of lamp 2. So if I want to measure the resistance of lamp 2, where I should connect a voltmeter and where I should connect an ammeter? You can use your screen annotation to draw the voltmeter and ammeter. Use the screen annotation to locate the position where I should connect a voltmeter and where I should place an ammeter to measure. Yeah, this is the position of voltmeter and where should be the ammeter. Yeah, yeah, that's right. Even before or after, you can. So you can see this voltmeter will give you the voltage. So you will have the voltage, and this ammeter will show you how much current is there. So voltage divided by current, you can calculate the resistance. If a question is connect voltmeter and ammeter, to measure total circuit resistance. So where you should connect, use the screen annotation. Yeah, so you have the voltmeter measure the total voltage, and ammeter measure the total current which is passing, and voltage divided by current, you will get the resistance of this whole circuit. Is it clear? The concept of measuring the resistance of a circuit by using voltmeter and ammeter. Okay, diagram shows a resistor connected in a circuit. The current in the circuit shown in the ammeter is 2 ampere and voltage across the resistor is 15. Calculate the resistance of resistor. What's the answer? What is the resistance? So voltage divided by current. So voltage is 15 and the current is 2. So it will be 15 divided by 2, which is equals to 7.5 ohms. So practically how we can measure the resistance? We already discussed this. If we want to measure the resistance of any sub component, we connect a voltmeter parallel and ammeter in series, and voltage divided by current will get the resistance. But there are factors which affect the resistance of a wire. So there are factors which affect resistance of the wire, like wire which are made up of metal. Example, if you have two wires of different length but same area, which one you think will have high resistance, greater tendency to oppose the movement of the charges? A or B? So B will have a higher resistance than A, because for the charges it's a longer passage. B is like a longer passage for the charges, so they will collide more often within the lattice. But for A, because it is a shorter passage, so shorter wires will have lower resistance than longer wire. And same thing, if you have two wires of same length but different cross sectional areas, which one you both have the same length but different areas, which one you think will have high resistance, A or B?
B.
B will have high
I
resistance.
mean,
Yeah, which one will you think will have high resistance, A or B?
high resistance A.
Actually, B is the right answer. Why B is the right
How?
answer? Because look, example, if three charges are entering within the between the charges, there's a repulsion. But B is a narrow passage. Like example, if three people enter a narrow passage, they will find it difficult to move through this passage because small space is available for them to move. But this is a wider passage, so charges can move relatively easier as compared to that of B. So thinner wires have high resistance than thicker wires. A will have more particle, but when you compare the length, like in the previous example, when we are comparing the length, so we said both have the same areas, but they have different lengths. So when the particles, these are the particles within the material. So when the charges enter, they collide with these particles which are present in the material. So example, if three charges enter here and same number of charges enter here, you can see less number of collisions. The particle will collide, but less collision, and they can go out. But here, as the charges are moving, they have to collide with a greater number of the particle. So means they will experience greater repulsion, or they will find difficult to move. That's why when you have a longer wire, if two wires have the same areas, but if the wire is longer wire will have high resistance than shorter wires. And the second one, we compare the areas if two wires have the same length but different cross-sectional areas. So when I draw the lattice, so if the passage is narrow, all the three charges, they have to go through this passage. They don't have any further space available. They have to go through this passage. But when greater cross-sectional area, the particle have multiple ways to flow, means they can take, like this particle can take this passage, go out, the other particle take the other passage and go out. So they have more space available for them for their movement. So that's why this will have low resistance, but this will have high resistance. Is it clear the concept how the cross-sectional area of a wire affects the resistance? So when the wire is thin, it will have high resistance. When the wire is longer, it will have high resistance. This one is having a large area, so you can see more space available for the charges to move. This one is having a small area, so there is small space available for the same number of charges to move. So example, if they say more charges were there, so six charges are moving here and same six number charges are moving here. So the overall each charge will get more space available to move. Here, narrow passage, so charges find it difficult to move. That's why thinner wires have high resistance than thicker wires. Is it clear? So factor which affects the resistance, number one, the length. If we have a uniform cross-sectional area, same cross-sectional area is there, The longer wire, the further electron have to travel. So they will have more collision. That's why it will have higher resistance. And it also depends on the cross-sectional area. So if the wires have the same length, the one which is having a small cross-sectional area, the one which will have small cross-sectional area will have higher resistance. So resistance and length are directly proportional, and resistance and cross-sectional area are inversely proportional. Means if you increase the length, resistance will increase. And if you increase the area, the resistance will decrease. So the formula which you can use, which can relate this resistance, length and area. So resistance is equals to length divided by area multiplied by rho. What is this rho? R is equals to rho L by A. What is this rho? This rho is called resistivity, and it is a constant for every material. This rho is known as the resistivity, and it is constant for material. Like example, copper is having its own resistivity. It's the same concept like density. Density of an object is constant. It does not depend on the shape or the size. So same concept is for resistivity. It's a fixed value for every material. So whenever we want to relate this formula which relate resistance, length and area, the formula is R is equals to rho L by A. And what is rho here? Rho is called resistivity, and it is a constant according to each material. Like copper will have its own resistivity, mercury, iron will have its own resistivity, aluminum will have its own resistivity. So even, for example, you have two wires made up of copper. They have different areas, they have different lengths. Example, three wires made up of copper. Wire A is also made up of copper. Wire B is made up of copper. Wire C is also made up of copper. So as these wires all are made up of copper, if they're made up of same material, this is made up of copper, this is copper, this is also copper. So what will happen? All these wires will have the same resistivity. Like it's the same concept when we compare the density of this piece will be same as density of A equal to density of B and density of equal to density of C. Because the materials are same, so they will have the same density, same thing. If materials are same, they will have the same resistivity. Resistivity does not depend on the shape or the size, it depends on the type of the material. And what is the meaning of the resistivity? Resistivity actually refers to, example, you have two wires which are made up of copper. One is large area and longer. Another one is small area and shorter. So what is the resistivity? Resistivity means when you take area of 1 meter square and length 1 meter. When you take area of 1 meter square, the cross-sectional area, and length of 1 meter. So resistance of this part is called resistivity. Same thing here. When I take an area of 1 meter square and length of 1 meter out. So when I take area of 1 meter square and length of 1 meter, resistance of this part is known as resistivity. So if this is made up of copper, this is also made up of copper. So if materials are same, the two wires will have the same resistivity. So resistivity does not depend on the length of a wire which we are using or the cross-sectional area. It depends on the type of the material, and it will be constant. So in the question, it will be given if they say a wire is made up of copper, it will have its own resistivity. If it's made up of iron, it will have its own resistivity. Resistance is if they will have different resistance. Resistance of A will be different from resistance of B. Maybe this will have a resistance of 80 ohm, and maybe this is having a resistance of, if I make it longer, maybe this is having a resistance of 200 ohm. So two wires will have different resistance, but if they are made up of same material, they will have the same resistivity, because resistivity is the resistance of part of the wire of area 1 meter square and length 1 meter. That's called resistivity. So two wires made up of same material, they may have different cross-sectional area, may have different length. So they will have different resistance, but they will have the same resistivity. So example, if two wires, one is having a large area and it is shorter, another one is greater area, sorry, smaller area. So one is having a large area and shorter, the other one is having a small area and it's longer. If and both wires are made up of copper, wire A is made up of copper, wire B is also made up of copper. Which wire you think will have high resistance, A or B? When you compare the resistance of the two wires.
B.
So when you compare the resistance, B is having, it's a longer and thinner. So B will have high resistance. But when you compare resistivity,
Same.
resistivity will be same, because resistivity is always a resistance of a wire of length 1 meter and area 1 meter square. So for resistivity of A will be same as resistivity of B.
Sir, in the exam, will they give us the resistivity of different
If
materials?
they are, no, most of the time they give the material resistivity, but sometime they can give you different resistivities, and you have to find, they give the resistance, length and area. So using resistance, length and area, you will find the resistivity and compare with the standard. So the question can be both ways.